Good afternoon, students. So, welcome to our online session. So, in digital signal processing and application, as you know, I'm going to teach you about DSPA subject for EEE 6th semester. In today's session, we are going to see in details about it, how the signal ends at its function by using the discrete Fourier transform and inverse discrete Fourier transform can be going to function. And we are going to see the twiddle factor as well, how the twiddle factor is going to be work for that, and based upon that we are going to work on the functionality. The main concept of R is how the DFT and IDFT is going to use a twiddle factor for 4.8 point. We are going to see in that, and even though we are going to understand what are the application part of it and how we are going to apply that concepts by using discrete Fourier transform, inverse discrete Fourier transform and fast Fourier transform. So these are the concepts we are going to see that one, right? So now in today's session I am going to teach you about that. And before proceeding ahead, just take a brief overview of a previous session, what we discussed in the previous session. In previous session we talk about the DFT and IDFT, the difference of DFT and IDFT, and we are talk about the functionals of it, how the twiddle factor is going to be used for DFT as well as for IDFT. Okay, so that concepts we already covered, and now in today's sessions we are going to learn more about it, DFT and IDFT, and then we are going to learn about the functionality of that function, how we can use for that by converting n domain signal into k domain signal, because in DFT you are converting n to k domain, right? For IFFT, for IDFT we are converting k domain into n domain. What about FT actually? For a transform we are converting n domain into frequency domain signal. So this part we already have covered. And now in today's session we are going to learn about it, how we are going to function by using these functions. So we are going to see that one as well, the functionality of it, and how we are going to use for that particular functions also we are going to cover in today's session. Okay, so let us proceed with that concepts and how we are going to use that one also we are going to see in our today's session. So students, so we are going to see about the DFT properties. In the previous session also we have talked about the properties of it. So we have talked about the symmetric property. What is symmetric? It is depends upon 4 points. One is symmetrical property to real wide loop function. If only if you get real parts is there is no imaginary part, then this is called symmetric property for real function. And real and even means only imaginary part should be 0, and the imaginary part of that domain if you convert that is also 0. If both the function for n domain imaginary part is 0, for k domain also 0, then that kind of function is considered to be the real and even sequence, right? For the same real and odd sequence, reverse of it. So xi of n is equal to 0 and xr of k is equal to 0. Real part of k domain and imaginary part of n domain both are 0, then we can say real and odd function. And for pure imaginary function, what we can say? X of n, that is xr of n is equal to 0, then we can consider as it is a pure imaginary function. This is the functions we have talked about in the previous session also. In today's session we are going to learn in detail about it further, what are the things we are going to learn it, and how this properties is used for the DFT, that is also we are going to understand and we are going to work on that. Okay, so those concepts we are going to cover in today's sessions, and we are going to see the further concepts what actually we do have for this particular DFT and IDFT. All those concepts we are going to cover in today's session. Okay, so we proceed with those sequence, with those particular functions, how it is going to work on it, and what are the parameters, it depends on that. If you do have even and odd functions, how do we segregate those functions, we are going to learn about it in today's sessions. So as you can see here students, so linear and circular convolution, this is an important question. So basically we know about linear convolution. How do we find the convolution? Basically, so when we had one function into another function, when one function is convolved with another function, we try to take a delay of that. We try to find delay of that particular function and we try to find the solution of it. That can be done by using matrix approach, by using graphical approach, by using the concentric circular method that is used for circular convolution, and matrix method also we are used for circular convolution. Likewise, we are going to use those particular functions. Okay, so that is also we are going to see in today's session. So basically, what is the linear convolution is all about, students? The linear convolution, how can you find? The linear convolution we can find by considering two sequence. Suppose you do have one sequence x of n, another sequence x y h of n, that is impulse response. You want to get the output of it. How do we get the output? To get the output, we'll write x of n impulse response of h of n, that can be given by the same output. Output is y of n, that can be calculated by using this linear convolution. What about circular convolution? Circular convolution is nothing but the multiplication of two DFTs is called as circular convolution. Whenever we try to find the DFT of two response, when you see that one, when it is forming that one, then we can find the circular convolution for that given sequence. Then multiplication of two sequence in time domain is called linear convolution. If you're using in time domain, students, if you're multiplying two sequence, then it is called linear convolution. What about circular convolution? Multiplication of two sequence in frequency domain. If you see the frequency domain, if you try to multiply the two sequence, then we consider that as a circular convolution. So linear convolution formula is what? Linear convolution is given by the equation y of n is equals to x of n convolves with h of n, right? Whereas circular convolution is written as y of m is equals to